Well, my 8th graders, I know that you guys have been looking forward to this video, and this third video is all about what we've been working on, and it's been analyzing graphs. So when we analyze a graph, what we're doing is we're taking a look at the actual coordinate system where we have a y-axis and an x-axis. And what we have to do is we have to know what the x and the y-axis stand for. Well, in this graph over here on the left-hand side, this y-axis stands for the speed. Now this speed could be for anything. It could be for a car, it could be for a plane, it could be for a person who's walking away. But this is a speed. And this x-axis is time. Right here, this is where the speed is 0 and the time is 0. So time has not started. Once I start moving to the right, more time has passed. The time is now increasing. Maybe 1 hour, maybe 2 hours, maybe 3 days. But the more you move to the right, the time has increased. More time has passed. On this other graph here on the right-hand side, we're still going to use the x-axis is equal to time. But the distance away from the starting point will be the new y-axis. You see, these are both two graphs for the very same story. But the reason why the graphs are different is because even though it's for the same story, the y-axis is different. This is distance away from the starting point, and this is the speed that something is traveling. Well, let's read this sentence, okay? You read this while I'm reading it right here for you. It says, a plane speeds up on a runway and reaches its top final speed and stays at this speed for 3 hours. So, let's imagine that you're on a plane. The plane hasn't started yet because you got on it. What is the speed of that plane? It's 0 miles per hour. The plane isn't moving. That's how come you were able to get on it. Is because the speed of the plane is 0. It's standing still. Well, that means that the speed and the time haven't started yet. That's why both of the graphs start at the origin. Well, at this point, the speed is going to start to increase. The plane needs to start moving at a faster and faster speed in order for it to make enough, speed so that it can pick itself up from the ground and fly into the sky, into the air. So the faster that this speed increases, you can see that the speed, maybe it's going 3 miles an hour, 4 miles an hour, 20 miles an hour. The speed is increasing the more time passes. But at some point, whatever it reaches, it stays at that final speed. It stays there for 3 hours. So is the speed going to keep on going up? Well, no, it's not. The speed will stay the same. See, the plane takes off and it hasn't started. It started at 0. Once the plane starts moving, it's going faster and faster and faster as time passes. Eventually, it's going to pick up from the ground into the air. It's going to reach its final speed. Time will keep on passing. Maybe 1 hour grows to 2 hours. Maybe 2 hours goes to 3 hours. But the speed of the plane stayed the same. This is why this is a flat line and the speed's not going up anymore. This line is totally flat. This graph is not the same though. This is for the distance away from the starting point. You see, if you take off from an airport, the longer you fly, the longer this time passes, the further away you get from the starting point. If you take off in Los Angeles and you fly for 3 hours, you'll be far away from LA. But if you take off from Los Angeles and you fly for 6 hours, you'll be further away from Los Angeles in 6 hours. So the longer you fly, the further distance away you are. But let's take a look at how this turns to curve. Let's see why it actually starts to look like this. When the plane first starts, it really isn't that far away from the airport. It's probably still on the runway. But the faster that the speed of the plane increases, okay, the faster that it starts to increase, the more the speed grows. And the further that the plane is going to go away. So at some point, the plane's going to keep on going faster and faster and faster, and it's going to keep on going further away. It's not going to keep at a same speed. It won't stay the same distance. The distance will increase. From here to here is shorter than from here to here. Notice that this distance is larger. This is why this graph looks like this for the distance away from the starting point, wherever you started from. We've been studying these graphs, and we'll be continuing studying these graphs. Hopefully this is going to help you out a little bit. You guys take care, and I'll see you guys next video.